What you are looking at is the first ever real image of a black hole released by NASA. Black holes in higher dimensions don't just crush you into a point, they do something far stranger. They could stretch you across dimensions of space you can't even perceive, while you remain completely conscious, experiencing realities that physics says shouldn't exist. And here's the disturbing part. According to string theory, these higher dimensional black holes might actually exist, not in some distant universe, but right here, potentially forming in particle colliders on Earth. Let me show you exactly what would happen to you if you fell into one. Before we dive into the nightmare scenario, you need to understand what dimensions actually are, because most people get this completely wrong. You live in 3 spatial dimensions: left, right, forward, backward, up, down. You can move freely in all 3. Add time as a 4th dimension, and you have space-time, the framework Einstein used to describe gravity. But mathematics doesn't stop at 4 dimensions. You can write equations for 5, 6, even 11 dimensions. These aren't just abstract concepts. Some of our best theories of physics, particularly string theory, require extra dimensions to work mathematically. Here's the key question. If extra dimensions exist, where are they? The answer might be that they're compactified, curled up so small that we can't perceive them. Imagine a garden hose. From far away, it looks one-dimensional, just a line. But an ant, crawling on it, experiences 2 dimensions. Along the hose and around it, the around dimension is curled up, invisible at large scales. Extra dimensions might work similarly, existing at scales smaller than atoms, invisible to everything except perhaps gravity, which could leak into these hidden dimensions. Now, if extra dimensions exist, black holes in those dimensions would behave very differently from the black holes we know. And that's where this gets absolutely wild. Chapter 1. What makes 5D black holes different? In our familiar 3D space plus time, black holes are relatively simple. They have an event horizon, a boundary beyond which nothing escapes. They have a singularity at the center, where physics breaks down. And they're spherical, the same from every angle. Einstein's equations describe them completely. We understand their properties, their behavior, how they interact with matter and light. 5-dimensional black holes are not like this at all. In 5D spacetime, that's 4 spatial dimensions plus time, black holes can have shapes that don't exist in our reality. They can be ring-shaped rather than spherical. They can have multiple event horizons nested inside each other. They can be unstable, changing shape dynamically in ways 3D black holes cannot. The mathematics was worked out by theoretical physicists, studying what's called Kaluza-Klein theory and later refined by string theorists. The solutions to Einstein's equations in 5 dimensions produce objects called black rings, black Saturn configurations where a ring orbits a sphere, and even more exotic structures. But here's what makes them truly terrifying. Their event horizons are not 3-dimensional surfaces. They're 4-dimensional hypersurfaces. Try to visualize that. You can't, because your brain evolved to process 3 spatial dimensions. A 4D surface existing in 5D space is literally beyond human visualization. But mathematics describes it perfectly. When you approach a 5D black hole, you're not falling toward a sphere. You're falling toward a 4-dimensional structure that intersects our 3-dimensional space in ways that would look absolutely bizarre. Imagine seeing an object that appears to be inside out and right side out simultaneously, that has surfaces that connect to themselves in impossible ways, that seems to be in multiple places at once. That's what a 5D black hole's event horizon might look like if you could somehow perceive the extra dimension. Since you can't, what you'd actually see is even stranger. Chapter 2. The approach. Let's say you're in a spacecraft approaching a 5-dimensional black hole. For this scenario, we'll assume you can somehow perceive the 5th dimension, even though that's physically impossible for 3-dimensional beings. This is purely to understand what's happening. At a distance, the black hole appears as a sphere, just like 3D black holes. This is because you're seeing its projection into 3-dimensional space, similar to how a sphere's shadow is a circle. But as you get closer, the geometry starts breaking the rules, you know. Objects near the black hole appear distorted in ways that violate Euclidean geometry. Straight lines, curve, parallel paths converge, and diverge randomly. Distances become ambiguous. This isn't just gravitational lensing, the bending of light by gravity that we see around normal black holes. This is geometric distortion caused by the extra dimension affecting how space itself is structured. Your spacecraft's instruments go haywire. Measurements of distance give different results depending on which direction you measure. The black hole appears to be different sizes from different angles, even though you're not moving. Then you start seeing the impossible shapes. The event horizon, which should be a smooth surface, appears to have features that can't exist in 3 dimensions. Surfaces that intersect themselves. Edges that lead to other edges without any corners. Holes that connect to themselves. You're seeing 3-dimensional slices of a 4-dimensional object, like how a sphere passing through a flat plane would appear as a circle that changes size. But your brain can't process these slices into coherent understanding. The image is geometrically contradictory. As you cross the event horizon, something even stranger happens. You don't necessarily notice the crossing. In a 3D black hole, you'd see the outside universe blue-shifted and compressed into a bright ring behind you. In a 5D black hole, the visual distortions are so severe that you might not even realize you've crossed the horizon. The boundary exists in the extra dimension, and your 3-dimensional senses can't properly detect it. You might be inside the event horizon, while still seeing what looks like empty space around you. The horizon could be in a direction you can't point to, a direction perpendicular to all 3 spatial dimensions you know. This is where the real nightmare begins. Chapter 3. Inside the horizon. Once inside, the rules change completely. In a normal black hole, all paths lead inexorably to the singularity. You're doomed to hit the center no matter what you do. It's not a location in space, it's a moment in your future, as unavoidable as next Tuesday. In a 5D black hole, the interior structure is far more complex. You might have multiple singularities. You might have regions where time flows in closed loops. You might encounter what's called a Cauchy horizon, a boundary where physics itself becomes unpredictable. Let's focus on what you'd actually experience. First, tidal forces. In a 3D black hole, tidal forces stretch you along the radial direction while compressing you perpendicular to it. This is called spaghettification, and it would rip you apart at the atomic level. In a 5D black hole, tidal forces operate in the extra dimension too. You'd be stretched and compressed in 4 spatial directions simultaneously. Since you're a 3D being, you can't stretch into the 4th dimension. So, what happens? The mathematics suggests you'd experience what's called dimensional reduction. Your 3-dimensional body would be projected onto different dimensional slices. Parts of you would be compressed into lower dimensions, while other parts remain 3-dimensional. This wouldn't feel like being torn apart. It would feel like parts of your body ceasing to exist while somehow still being connected to you. Imagine your arm disappearing not into space, but into a direction you can't perceive. You'd still feel it, still control it, but it would be invisible, existing in a dimension perpendicular to your senses. Your perception of time would also fracture. In the extra dimension, time might flow at different rates. Part of you could be experiencing seconds, while another part experiences hours. Your consciousness, somehow distributed across these dimensional fragments, would experience contradictory timelines simultaneously. You'd be seeing your own past and future overlapping with your present. Causality would break down. Events would happen in your experience before their causes occurred. You'd remember things that haven't happened yet while forgetting things that are currently occurring. And you'd be completely conscious throughout this. Your neurons would still fire. Your brain would still process information. But the information it's processing would be coming from multiple dimensional slices of reality, creating an experience no human psychology is equipped to handle. Chapter 4. The Singularity Encounter. As you approach the singularity, or singularities, the dimensional effects intensify. In a 3D black hole, the singularity is a point of infinite density. In a 5D black hole, it might be a ring, a string, or some higher dimensional structure. If it's a ring singularity, you have a choice that doesn't exist in 3D black holes. You can pass through the ring instead of hitting it. This is predicted by the mathematics, though what happens when you do is purely speculative. Some solutions to the equation suggest that passing through a ring singularity could take you to another region of space-time. Not another universe, but another section of the same space-time with different properties. Negative mass might exist. Time might run backward. The speed of light could be different. This is where we enter pure theoretical territory. No one knows if these mathematical solutions represent physical reality or are just artifacts of the equations. But let's follow the scenario to its conclusion. Passing through the ring, you'd experience a moment where all dimensional boundaries dissolve. Your 3D body would simultaneously exist in all possible dimensional states. You'd be a point, a line, a surface, a volume, and a hypervolume all at once. The sensation would be of infinite compression and infinite expansion simultaneously. Every point in your body would feel like it's the center of the universe and the edge of the universe at the same time. Then, emerging from the ring, you'd reform, but potentially not in the same dimensional configuration. The mathematics allows for the possibility that you could emerge as a 4-dimensional being, your body now extended into the previously hidden dimension. What would this feel like? You'd have an entirely new degree of freedom for movement. You could move in a direction perpendicular to all 3 familiar dimensions. Objects that appeared solid would have hollow interiors accessible from this new direction. You could reach inside closed containers without opening them, moving your hand through the 4th dimension. Your senses would also expand. You'd see the insides and outsides of objects simultaneously. You'd perceive time as a spatial dimension, seeing your past and future as places you could theoretically visit by moving in the right dimensional direction. But here's the cosmic horror. You'd also realize that your original 3-dimensional existence was a shadow, a projection of a larger reality. Everything you thought was complete and whole was actually just a slice of something bigger. And you could never go back. Your body is now 4-dimensional. Returning to 3D space would require squashing an entire dimension of your being out of existence. You'd have to lose part of yourself permanently. Chapter 5. The physics. Let me ground this in actual physics, because I know this sounds like science fiction, but every aspect I've described comes from legitimate mathematical solutions to Einstein's field equations in higher dimensions. The first complete solution for a 5D black hole was found by adding an extra dimension to the Schwarzschild solution, which describes non-rotating 3D black holes. This produced something called the Schwarzschild-Tangerlini metric. This solution predicts event horizons that are 3-dimensional spheres embedded in 4-dimensional space. The area of this horizon, which in 3D determines the black hole's entropy, is now a volume in 4D. All the thermodynamics of black holes gets modified. Then came the Myers-Perry solution, which describes rotating black holes in higher dimensions. These can have ring singularities and much stranger behavior. In 5 dimensions, you can have black holes that rotate in 2 independent planes simultaneously, something impossible in 3D. The black ring solution, discovered in 2002, showed that 5D black holes don't have to be spherical at all. They can be ring-shaped, with the radius of the ring and the thickness of the ring being independent parameters. This means you can have infinitely thin rings, or fat rings, all with the same mass. Even stranger, you can have black Saturn configurations, where a ring orbits a central sphere, both in equilibrium. These have no analog in 3D space. The instabilities are real too. Some 5D black holes are predicted to be unstable, spontaneously deforming and potentially splitting into multiple black holes, or emitting gravitational waves until they settle into a stable configuration. All of this is mathematically rigorous. These aren't guesses. They're solutions to Einstein's equations in 5-dimensional spacetime that satisfy all the mathematical requirements for consistency. The question is whether they're physically real. Do extra dimensions exist? Are black holes in those dimensions actually possible? String theory says yes. The theory requires 10 or 11 dimensions, most of them compactified. If string theory is correct, higher dimensional black holes must exist somewhere, somehow. Some theorists proposed that the Large Hadron Collider might create microscopic black holes if extra dimensions exist at accessible energy scales. These black holes would be 5-dimensional or higher, existing briefly before evaporating through Hawking radiation. The LHC hasn't detected any such black holes. which constrains where extra dimensions could be, if they exist at all. Either they're smaller than we can probe, or they don't exist in the way string theory predicts. But the mathematics remains valid. If extra dimensions are real, 5-dimensional black holes are real, and their properties are, as I've described. Chapter 6. What this tells us about reality. Beyond the nightmare scenario of falling into one, what do 5D black holes tell us about the nature of reality? First, they demonstrate that our experience of 3-dimensional space might be incomplete. We might be living in a higher dimensional reality, perceiving only a slice of what actually exists. This isn't mysticism, it's a serious possibility arising from our best mathematical descriptions of physics. The universe might have more dimensions than we can directly observe. Second, they show that the familiar concepts of space and time are more flexible than we imagine. In higher dimensions, time can flow differently in different directions. Space can curve in ways that create impossible geometries by 3D standards. Third, they suggest that consciousness and perception are dimensional. If extra dimensions exist, beings evolved to perceive them would experience reality in ways we literally cannot imagine. To them, our 3-dimensional existence would seem impossibly constrained and limited. Fourth, they reveal deep connections between geometry and physics. The reason higher dimensional black holes behave so strangely is that geometry itself works differently when you add dimensions. Physics doesn't change, but the geometric stage on which physics plays out becomes richer and more complex. Finally, they highlight how much we still don't understand about the universe. We can write the equations, we can solve them mathematically, but we can't yet determine if those solutions describe physical reality or are just mathematical curiosities. This uncertainty is both humbling and exciting. We've come so far in understanding the cosmos, yet mysteries remain that might require entirely new physics to resolve. So what would you see if you fell into a 5-dimensional black hole? You'd see the impossible, geometries that can't exist in 3 dimensions, objects that are simultaneously inside out and right side out, surfaces that connect to themselves in contradictory ways. You'd feel your body stretched across dimensions you can't perceive. You'd experience time flowing in multiple directions at once. You'd see your past and future overlapping with your present. And if you somehow survived passing through the singularity, you might emerge transformed into a 4-dimensional being, forever unable to return to the 3-dimensional reality you came from. This isn't science fiction. This is what the mathematics of general relativity predicts for black holes in higher dimensions. Whether such black holes actually exist remains an open question. But the fact that our best theories even allow for such possibilities shows how strange reality might be beneath the familiar surface we perceive. The next time you look at the night sky, remember, there might be entire dimensions of reality perpendicular to everything you can see. Dimensions where black holes create geometries and experiences that would shatter human understanding. We live in a strange universe, and it might be even stranger than we know. What do you think? Could extra dimensions really exist? Would you want to experience higher dimensional reality if you could? Let me know in the comments. And if you want more deep dives into the physics of black holes and higher dimensions, subscribe, because we're just beginning to understand how truly bizarre the universe can be.